All right, so let's talk about factoring quadratic polynomials. All right, so first of all, let's multiply this this number times this quadratic polynomial. So remember, if I multiply, I'm going to use the distributive property. So I'll have negative 15x squared, and then plus 35x, and then minus 5. All right, so we know how to multiply that using the distributive property. Say I wanted you to factor this. So we could look and see if there's a number that goes into each one of these terms, each one of those coefficients on the terms. And notice that negative 5 will go into each one of those, obviously, because we just multiplied negative 5 times. But pretend we hadn't done this, we would notice that negative 5 goes into each one of those. So we could undo the distributive property, do the distributive property backwards, unmultiply. Okay, so if I did that, I would factor out the negative 5 and then see what's left in there. So obviously negative 5 times 3x squared would give me that. Negative 5 times minus 7x would give me plus 35x. And then negative 5 times 1 would give me negative 5. And you see I got back where I started. So factoring is just undoing multiplication. Okay, this negative 5 is called a common factor. I factor out a common factor of all those. And in fact, in this one, it is the greatest common factor. So the first kind of factoring we'll talk about is finding the GCF, or the greatest common factor. So let's try one. So I want to factor, let's say 14x squared plus 21x minus 28. Okay, so I can look at that and try to find the greatest common factor. So is there a number that will go into 14, 21, and 28? Well, 7 will. So I can factor out a 7 and see what that leaves me. So 7 times 2x squared will be 14x squared. 7 times 3x will give me 21x. And 7 times minus 4 will give me negative 28. So 14x squared plus 21x minus 28. So we factored out the greatest common factor of 7. Let's try a different one. Let's try this. 8x to the third minus 5x squared plus 13x. Okay, so let's see if we can find the greatest common factor. So is there a number that will go into 8, negative 5, and 13? Not really. But notice that there's an x in each one of those terms. So here I could factor out an x. If I did that, I would be left with 8x squared minus 5x plus 13. Double check ourselves, just distribute the x through. X times 8x squared is 8x to the third minus 5x squared plus 13x. Okay, let's try one more example of the GCF. Let's factor, of course we weren't multiplying that, we were factoring. Let's factor, let's say 10x to the fifth plus, well, let's make it minus 10. Minus 10x to the fifth plus 7x to the fourth. Excuse me, 8x to the fourth minus 12x to the third. Okay, so negative 10x to the fifth plus 8x to the fourth minus 12x to the third. All right, let's find the GCF. So is there a number that will go into 10, 8, and 12? Well, 2 will. Most of the time, or often, we would like to have this leading coefficient positive. So instead of factoring out a 2, let's factor out a negative 2. So negative 2 will go into each one of those coefficients. Notice also that there's an x in each term. So I can bring out the greatest common factor of all these all the x's in the terms. Okay, so the biggest one, and in fact the one with the smallest exponent, but the biggest common factor that we could get out would be x to the third. So what do we have left then? This would be 5x squared, and that would be minus 4x, and this would be plus 6. So let's double check. Negative 2x to the third times 5x squared is negative 10x to the fifth. Remember, we add the exponents. Negative 2x to the third times negative 4x would be 8x to the fourth, and understood 1 right there. And negative 2x to the third times 6 would be negative 12x to the third. So we have factored out the greatest common factor of negative 2x to the third. All right, so let's multiply these two binomials together. These are called binomials because there are two terms in it. One term, two term, that's one binomial. One term, two terms, that's another binomial. All right, so as you guys know, to multiply these, we distribute this first term times each term in the second. So we'll get x squared plus 3x, and then we multiply these, and I get plus 7x plus 3. No, not plus 3, plus 21. All right, notice that we have two like terms in the middle, so we can combine those and get x squared plus 10x plus 21. So let's think about where these numbers come from. So this x squared comes from multiplying the first two terms. That's where the x squared comes from. The 21 comes from multiplying the 7 and the 3, the two last terms. This 10x in the middle, let's think about where it comes from. It comes from the 3x and the 7x. So it comes from the product, from the sum of the product of these two and these two. So here's the 3x, here's the 7x. So it's really important to understand where each one of these terms come from. So again, this x squared comes from these two. 21 comes from these two. And the 10x comes from the sum of these two and these two. So you need to really understand that. All right, so what if I just gave you this and told you to undistribute it or unmultiply it and turn it back into this? So that's what we're going to do now. We're going to factor quadratic polynomials that look like this: x squared plus bx plus c. So notice this is x squared plus bx plus c. So we're going to factor ones that look like this trinomial into two binomials. This is a trinomial, 1, 2, 3 terms. Factor this trinomial into two binomials. All right, so let's do one. Let's factor x squared plus 7x plus 10. Does this have a GCF? Does it have a greatest common factor? Is there a number that will go into 1, 7, and 10? No. This term doesn't have an x in it, so we can't factor out an x. So there's no GCF. So let's try to factor this trinomial into two binomials. So let's draw our parentheses. How do we get x squared? Well, we would get that from an x and an x. How do we get the 10? Well, we could get that from either a 10 and a 1 or a 2 and a 5. Okay, let's try a 10 and a 1. Okay, so think about what would happen then if we multiplied this out. So I would get x squared, and I would get 1x, and I would get 10x. Is there any way to add or subtract a 1x and a 10x to get a 7x? No, you would either get an 11x or a 9x or something like that. There's no way to get a 7x. So that wouldn't work. But what would work is a 5 and a 2. So now I've got the x squared, I've got 2x and 5x. I can get a 7x out of that. I just have to get the signs right. So if I put a plus here and a plus here, triple check it, x squared plus 2x plus 5x is 7x, and then plus 10 is there. So we have that factored correctly. Let's try another. So let's do x squared plus 3x minus 28. Okay, so question number 1, does that have a GCF? No, it doesn't. So let's try to factor this trinomial into 2 binomials. So here and here, I will need an x to get the x squared. Here and here, I'll need 2 numbers that multiply to give me negative 28. So if these 2 numbers multiply to give me a negative 28, I know the signs have to be different. One needs to be plus, one needs to be minus. My choices to get a 28 are 1 and 28, 2 and 14, and 4 and 7. Let's try the 4 and the 7. So if I do that, I get x squared, I get a 4x and a 7x. Can I get a 3 out of a 4 and a 7? I can if I subtract them, right? If I do 7 minus 4. So if I wanted to do 7 minus 4, I will need plus 7, and I'll need minus 4. Right, let's check and make sure that works. So x squared minus 4x plus 7x is 3x minus 28. And we have that factored correctly. Let's try another. Squared minus 4x minus 12. Okay, so question number 1, does that have a GCF? No, it doesn't. So let's see if we can factor this trinomial into the product of 2 binomials. So I will need an x and an x. 2 numbers that multiply to get me 12. Well, my choices are 1 and 12, 2 and 6, 3 and 4. How do we know which one of those works? Well, we got to kind of just multiply this out and see. We know that the 2 numbers will need to add to get me negative 4. So let's think about it. 1 and 12. Is there any way to add or subtract a 1 and a 12 to get a 4? No, you would either get a 13 or an 11. You can't get 4 out of that. All right, what about 2 and 6? Well, if you add 2 and 6, you get 8. If you subtract 2 and 6, you get 4. Maybe. So let's see if we can get the signs to make it work. Let's put a 6, a 2. Okay, so I know the product of these has to be negative 12, so I know the signs are different.
Mr. Box, call 1-200, please.
So I know the signs have to be different. So one's got to be a plus, one's got to be a minus. They have to add to be negative 4. So I'm going to need a minus 6 plus 2. Okay. Does that work? X squared plus 2x minus 6x is minus 4x. That's good. It's negative 6 times 2 is negative 12. But we have that one factored. All right, let's try to factor this trinomial. Okay, so the first thing you should always check, is there a greatest common factor? In this case, there is, right? So 2, or negative 2, 16, and negative 30. Notice 2 will go into all of those. And it's usually better if this leading coefficient is positive, so let's factor out a negative 2. Notice also that there's an x in each term. So let's factor out the greatest common factor of those. The greatest common factor of those will be the one with the smallest exponent, so the x to the first. So let's factor out x, and then we'll see what we have left. So negative 2x times x squared, give me negative 2x to the third. Negative 2x times minus 8x will give me 16x squared. And negative 2x times plus 15 will give me negative 30x. And I'm going to double check myself. So this times this is negative 2x to the third. That's good. This times this is 16x squared. That's good. This times this is negative 30x. So very nice. All right, so we got the GCF out. But now, can we factor this trinomial into the product of two binomials? So I will need an x and an x. And I need two numbers that multiply to give me 15 and that add up to get negative 8. Okay, so how about negative 5 and negative 3? Does that work? Let's check. X squared minus 3x minus 5x is negative 8x. Negative 5 times negative 3 is positive 15. So we've got it. All right, let's look at these two interesting examples. All right, so I want to factor x squared plus 6x plus 9. There's no GCF, so let's see if we can get it factored into two binomials. So I'll need an x and an x. Two numbers that multiply to get 9 and add to get 6. Well, that would be plus 3 and plus 3. Double check. X squared plus 3x plus another 3x is plus 6x, and then plus 9. All right, so that's good. That's right. But notice that these two are the same, x plus 3 and x plus 3. So we could write it like this, x plus 3 squared. So x plus 3 all squared means x plus 3 times x plus 3. Remember that you cannot apply this exponent to both of those. This is not x squared plus 9. Okay, you can't just put the 2 here and the 2 here. It's not x squared plus 9. Because if you multiply that out, you would have to do x plus 3 times x plus 3, and you would get this middle term. Okay, so make sure you don't make that mistake. All right, over here on the other one, there's no GCF, so let's try to factor it. I'll need an x, and I'm going to need two numbers that will multiply to get 16, but add to get negative 8. So that would be minus 4 and minus 4. X squared minus 4x minus another 4x is minus 8x, and then plus 16. Notice that these are the same. So I could write this as x minus 4 squared. All right, so far, we've learned how to factor out a GCF, greatest common factor. We know how to factor trinomials that look like this into the product of two binomials. And now, where I say perfect squares here, this is what I mean, the ones that factor into a perfect square, something squared. Okay, so we know how to do the first three so far. Next, we'll look at a difference of squares. All right, let's multiply these two binomials together. These two binomials are special. They're called conjugates. Okay, these two are conjugates. So conjugates look like this. The first two terms are the same, and the second two terms are opposites. So I have x plus something, x minus something, or the somethings are the same. So x plus 3, x minus 3, those are conjugates. When you multiply two conjugates together, something really special happens. So let's see what that is. So x times x is x squared. X times minus 3 is minus 3x. 3 times x is plus 3x. And 3 times negative 3 is minus 9. Notice that the two middle terms cancel out. And I'm left with x squared minus 9. Notice that 9 is a perfect square. It's 3 squared. This is called a difference of squares. Difference means minus. There's a minus sign between them. And both of these are perfect squares. I have x squared minus 3 squared. So two perfect squares, minus sign between them. These are differences of squares. A difference of squares will factor as two conjugates. Okay, so if you see a perfect square minus another perfect square, you know that it'll automatically factor into two conjugates. Let's try one. Let's do x squared minus 25. So I have a perfect square, and 25 is a perfect square. 25 is 5 squared. There's a minus sign between them, so this is a difference of squares. So I know automatically that that will factor as two conjugates. It'll factor as x plus 5 and x minus 5. We can double check that. X squared minus 5x plus 5x, that's 0 x's. Middle terms cancel. And then I got minus 25. Let's try one more. X squared minus 36. So this is a difference of squares. We can factor it as two conjugates. So x and x. And it'll be x plus 6 and x minus 6. Double check, x squared minus 6x plus 6x, those cancel. Negative 36, and I've got it. Let's do one more of those. Let's do 5x squared minus minus 500. All right. So I have a difference. Oh, wait, 500, that's not really a perfect square. 5 is not a perfect square. That doesn't look like a difference of squares. But what should we always look for first? See if there's a greatest common factor. Is there a GCF here? Yes, there is. I can pull out a 5. So I'll have 5 times x squared minus 100. Aha, that looks better. This is a difference of squares. Okay, so keep the 5 there. And we will factor that difference of squares into two conjugates. X plus 10 and x minus 10. Okay, something to keep in mind. If I wanted to multiply this 5 times all of that, I could distribute it to these two. And I would get 5x plus 50. And I would have x minus 10. Okay. You don't multiply the 5 with both of these. Okay, so for instance, if I did 2 times 3 times 4, I would do 2 times 3 and then times 4. I wouldn't do 2 times 3 and then 2 times 8. Right? So this 5 only goes with the first one if I wanted to multiply it out. But you really don't want to do that because then it's not factored. We could pull a GCF out of the first one. So we wouldn't want to do that. But if you did, make sure you do it correctly.